I'm going to explain where our law of cosines equation comes from. That's this one, c squared equals a squared plus b squared minus 2ab cos theta. We can use that when we have a triangle that we're given two side lengths and an angle theta, and we need to find the opposite side length from the angle theta. This can be used for any triangle. It is like Pythagoras, but it's better than Pythagoras because we can use it when we don't have a right angled triangle. So, where it comes from, first we're going to draw a line that is perpendicular with our side A here and passes through that vertex, which gives us two 90-degree triangles. Down here. Now we're going to find out what these other sides are. We're going to label them, let's go D, E and F. And if we find out what these are in relation to A, B and theta, we can then find out what C is. So D is adjacent to theta, so we'll use our cos theta cos theta equals D over B, and we'll solve for D, gives us B cos theta. Our F is opposite theta, so we'll use sine theta equals F over B. Solving for F gives F equals B sine theta, and then all we need is our E, and E is equal to this length A minus D. But we already know what D is because we solved for D here. D is B cos theta, so A minus B cos theta. So now that we have our E and our F, you can see that we could use Pythagoras for this section here, knowing that A squared plus B squared equals C squared, or let's look over here. F squared plus E squared equals C squared. Actually, I'm going to do that the other way around. We'll say C squared equals, now F is B sine theta squared plus E is A minus B cos theta squared. So that's a formula you could use to find out what C is, because all we have are our B's, A's and thetas. The rest of this just comes from simplifying. So to do that, we'll first start with doing these squares. So we have C squared equals B squared sine squared theta plus, okay, this one has a minus sign, so we need to multiply both these terms by both these terms. So A times A is A squared. A times negative B cos theta is negative A B cos theta. And then we need to do negative B cos theta times A, so that's just another one of those, so we'll make it negative 2AB cos theta. And negative B cos theta times negative B cos theta is negative times negative is positive, so it'll be plus B squared cos squared theta. And now what we're going to do is see if we can simplify this any further. We have a B squared on this term here and the B squared on this term here, so we can factor that B squared out, and I'll just rearrange it a little bit too. So we have C squared equals, I'll take this term, A squared here, and we'll do our b squared factored out of plus sine squared theta from here, and cos squared theta. Now, why we've done that, this term minus 2ab cos theta, is because sine squared plus cos squared, sine squared theta plus cos squared theta actually just equals 1. And we covered that in a previous lesson. I've done the working out here if you want to revise why that is. Cos squared theta plus sine squared theta equals 1, so that will just times by 1 just cancel itself out. So we're left with c squared equals a squared plus b squared minus 2ab cos theta, and that's the formula we're given to normally solve for these triangles. I don't know why we don't go further with that and just take the square root and say c equals the square root of a squared plus b squared minus 2ab cos theta. To me that makes more sense, because then you can see it's just a solution for c, and all you need is your a's, b's and theta. So if you have this, this and this, you can solve for that, but this is the way you'll normally see it written down.